Hello, our semester project for traffic modeling and simulation course is Green Light Optimal Speed Advisory or GLOSA algorithm using vehicle to infrastructure communication. This project is collaborative effort of Mr. Zihao and Muhammad Saqib Javed. Our goal is to demonstrate how GLOSA can optimize traffic flow and reduce unnecessary stop at intersections and junctions. So the project methodology we use for this project is like we test for testing GLOSA implementation, we built a simulation environment. So we use the instant vein omelette plus plus, which is a combination of omelette plus plus and veins, and we also integrated it with realistic sumo network. Within the realistic sumo network, we selected a specific lane and intersection to focus. Then we set up a traffic light, and then we selected our road, place the roadside unit nearby on the road, near the road, and the roadside unit is the key infrastructure component here. It acts as a bridge between the vehicle between the all the vehicles and infrastructure of traffic, which includes like traffic light controllers and similarly where the GLOSA algorithms are implemented. So the core of our project is GLOSA algorithm running on the RSU. It calculates the optimal velocities and sends them to the vehicles by using RSU. So this is the glimpse of our simulation, how it is running. Like there is the RSU unit placed on the road and vehicles are communicated with RSU for the information regarding the traffic lights, and based on the GLOSA algorithm there will be some vehicles are stopping at red light and some vehicles are continuously running in the green time. So the next this slide shows the glimpse of our code structure of our project within the instant veins environment. We have specific C++ classes and omelette++ NAD files defining the behavior of both the GLOSA enabled car and RSU GLOSA car. These files handle the logic for processing messages, calculating distances, and adjusting vehicle speed. The communication is handled through custom messages which are run on a C++ loop, and packets are defined in a GLOSA packet. The RSU broadcasts these packets to nearby vehicles. Crucially, these packets contain the information like the traffic light ID, its current state, green or red, and the remaining time for the current phase and distance to stop line from the vehicle. This data is essential for the vehicle to make a good informed decisions and very crucial for GLOSA implementation. And here we can see the C++ code running on the RSU where it decides the different phases of the vehicle, and RSU continuously monitors the traffic light program. It determines the current phase like green, yellow or red and calculates the time left until the next phase change. It then packages the real-time data into a GLOSA packet and broadcasts it to the network to the all the V2I connected vehicles. So this is the heart of the logic of our main project where the GLOSA is implemented. There are two different scenarios for this. When the car receives a packet, it first checks the traffic light status, either it's green or red. So in the first case, it calculates the time of green light and vehicle speed scenario. If it can pass the green light, then it maintains the its constant speed, and crosses the signal without any stoppage at this without any reduction of speed and any stop at the signal. And the second scenario, if the light is red, the algorithm calculates a target speed. The goal is to arrive at intersection just as the light turns green or slightly after to avoid a full time stop of vehicle. So we added a target buffer of approximately 5 seconds. This means the car aims to arrive 5 seconds after the green phase starts, ensuring a smooth transition and accounting for any delays. So and then further, this is the formula we use the for the which gives us the optimal speed for vehicle to maintain. If this is the if the target speed is feasible and above a minimum threshold, the car automatically adjusts its speed. And this is like the first slide is the how the these are the results of our simulations. And the first case, here's the speed profile for vehicle against time when GLOSA is not implemented RSU. So the vehicle maintains a high speed until it gets close to integration. In it comes close to any the intersection point or a signal, then it is forced to brake hard and complete stop, like its speed is reduced to totally zero, and to wait for then the green light to start. After the light turns green, it has to accelerate from a standstill situation to maintain its original speed. So this causes like a huge loss in the fuel efficiency and carbon and causes a lot of carbon emissions in this case. And there is this next scenario when we implemented the GLOSA. Uh, in this case, the vehicle approaches the signal. Without GLOSA, the car would have drive to the line and stop completely. With GLOSA, you can see in the chart, the vehicle receives the advisory and maintains its constant speed and passes the signal without a stoppage or slowing down. It maintains the speed and timing of its arrival for the green phase. And the second scenario, we see the ideal outcome. The vehicle receives the GLOSA message well in advance, so it adjusts its speed to match the green window. Like in this is the green time. This is like the red time, and the next is the green time. The result is that the vehicle passes through the junction without ever coming to a complete halt. Like it doesn't come to zero. It has some speed, but it is slow for some time. Just it slows down the vehicle, but speed now reaches to zero. As per GLOSA advisory, the vehicle passes the junction without stoppage. Comparing it to the above graph, a smooth deceleration followed by a acceleration once the light turns greens, maintaining moment which maintains the momentum throughout. It is clearly shows that the GLOSA reduces the time spent at zero velocity and smooths out the driving profile, which also saves the fuel and also reduces the CO2 emission. Thank you very much for your. This is all from our side, and we have demonstrated a V2I based GLOSA system which can effectively guide autonomous vehicles to optimize their speed, reducing unnecessary stops and improving traffic flow efficiency.